Okay, here is one of the examples that I did not get a chance to go over in section 3-5 when we were dealing with rational functions and their graphs. Here I want to graph f of x is equal to 4x over x squared minus 4. And I'm going to use the 7-step procedure for graphing a rational function. Okay. All right, step number 1 is determine whether or not we have symmetry. It could be y-axis symmetry or origin symmetry or no symmetry at all. And in this case here, we just have to replace the x with negative x in that original function to see what type of symmetry we're going to have. So we got 4 times negative x. I'm replacing the x with negative x. X squared, x is replaced with negative x, and that's going to be squared minus 4. Now we'll just simplify the numerator and the denominator. 4 times negative x will be negative 4x. Over, we square a negative, it's going to be positive, so negative x and you square it will be x squared minus 4. Now watch what happens when I take that negative sign and put it in front. I'm going to have the negative and then 4x over x squared minus 4. And as you can see here, I do have the opposite of the original function that I started off with. Okay? So when I have the opposite of the original function, that means that this graph is going to be symmetric with respect to the origin. So when I graph this function, I'm going to have origin symmetry. Alright, so that's step number 1. Number 2 is determine what the y-intercept is going to be. And we just simply replace the x with 0 in the original function to get that y-intercept. So it'll be f of 0 here is equal to, the numerator is 4 times 0, and your denominator will be 0 squared minus 4. Well, the numerator, 4 times 0, is 0. The denominator is 0 squared, that's 0, minus 4, which is negative 4. And 0 divided by negative 4 is 0. So the y-intercept will be the ordered pair 0, 0. And then step number 3 is finding the x-intercept of the graph of that rational function. Now, I did tell you that when you find your x-intercept, you always take your numerator and set that equal to 0. So we're going to take 4x and set that equal to 0. So it'll be 4x equal to 0. And then divide both sides by 4. You'll get x is equal to 0. So here, the ordered pair 0, 0 is also going to be the x-intercept. So your y-intercept and your x-intercept are going to be the same. Alright, number 4 is finding the vertical asymptote. Anytime you want to find the vertical asymptote, you take your denominator, which is your x squared, minus 4, and set that equal to 0. And solve for x. And what I'm going to do here is get the x squared by itself by adding 4 on both sides. So you got x squared is equal to positive 4. And the opposite of squaring something is always taking the square root on both sides. So here you got x is equal to, and if you take the square root on both sides, you have to bring in the plus or minus symbol. So here, it'll be x is equal to plus or minus 2. So that means x is equal to 2 and x is equal to negative 2 are going to be the two vertical asymptotes. That's going to be those two vertical dotted lines that will be on the graph crossing the x-axis at 2 and at -2. Step number 5 is finding the horizontal asymptote. Now, to find the horizontal asymptote, we have to compare two things, n and m. The n is going to be the highest exponent in the numerator. In this case, the highest exponent in that numerator is the understood 1. So n is equal to 1. The m is the highest exponent in the denominator. In this case, the highest exponent in the denominator is 2. So m is equal to 2. Now you're going to compare n and m to determine whether or not you have a horizontal asymptote and what that horizontal asymptote would be. Well, here 1 is less than 2. So that means n is less than m. And I did give you the cases where if your highest exponent in the numerator is less than the highest exponent in the denominator, that means that the equation y is equal to 0 is the horizontal asymptote. In this case, n is less than m. That means y is equal to 0, or the x-axis will be the horizontal asymptote. Now, step 6 and step number 7, I'm going to do side by side. Because step number 6 is just a table of values, step number 7 is doing the graph. So we have a table of xy values that I'm going to have. Now what I'm going to do here is graph what I already have. I know what my x-intercept is, and I know what my y-intercept is. They're both the same. It's the origin, 0, 0. So I'll go ahead and plot that. Then I'm going to put in place the vertical and horizontal asymptotes. One of my vertical asymptotes is x is equal to -2. That's going to be this vertical dotted line going straight up and down like this. And the other one is a +2. That's the other vertical dotted line going straight up and down, going through 2. Now my other is the horizontal asymptote, which is the x-axis. Y is equal to 0. That's this x-axis right here that I'm going to draw a horizontal line like this. Alright. Now, to get values of x, I'm going to pick points on the left and the right of each vertical asymptote and each x-intercept. Well, my first vertical asymptote is that x is equal to -2. I'm going to use x values like -3, -4, and -5. And to the right of -2, I'm going to use -1. Now my x-intercept is at 0, so to the right of that, I'll use x is equal to 1. Now, my other vertical asymptote is at 2, so let's use 3, 4, and 5 as x values. Okay, now I'm going to go ahead and use my graphing calculator to come up with the y values here. Okay, let me do second quit. Okay, now to start this, we're going to use the y equal to, and I'm going to clear this equation out in y1, and make sure that all of your plots are not highlighted. If they are, then you have to use your up arrow key to highlight the ones that are on, and then press enter to turn them off, and then use your down arrow key to go back to y1. Now, the numerator and the denominator I'm going to put in parentheses here. So in this case here, that 4x will be in parentheses, so I do left parentheses, type in the 4, And then I'm going to use the xt theta for the x. And then close the parentheses. And then that's going to be divided by, the denominator will also be in parentheses as well. So it'll be left parentheses. For the x, it'll be the xt theta for the x. For the square, you have to press this x squared button down here for your exponent of 2. And then minus 4. Close parentheses. And then to get your table, you're going to press the second key and then graph for your table. And in my case, I'm going to use the up arrow key to get my x values here. And I'm going to round each of these off to 1 decimal place here. So for like x equal -5, I got -0.9524. Let's round that off to like -1.0. We know it's not exactly -1, but we're just rounding. And then for -4, that will be -1.33, or just 1.3. Number 3, x equal -3, it'll be -2.4. Now at -2, it says error. That's one of your vertical asymptotes, because at -2 you would get a 0 in the denominator. Now for -1 to 1 decimal place, it'll be 1.3. And for 0, 0, that's your x and your y intercept. And then for 1, that's -1.3. I'm going to use my down arrow key to get to these last ones. For 2, that's the other vertical asymptote. That's why you see the word error there. At 3, it's 2.4. And at 4, 1.3. And finally at 5, I'm going to say approximately 1.0. We know it's not exactly 1.0, but we're rounding to 1 decimal place. Okay, now if you look at your table here, you can see at -5 and +5, the y values are opposites. That's why it has origin symmetry. The same for -4 and 4. The y values are opposites of each other. And the same for -3 and 3. They're opposites. -1 and 1. Again, the y values are opposites. So now I have enough information to do the graph of this rational function here. So for -5 and 1.0, now I'm going to go to the left 5, but I'm going to go down, and I'm not going to be exactly at 1, because actually that's like -0.95. And then -4 and -1.3 to the left 4 and down 1 and 3/10 of the way. And some of these you just have to kind of guesstimate. -3 and 2.4 would be like somewhere around here. Now I know what one part of this graph is going to look like. This end, if I come down this way, it's going to approach this first vertical asymptote like this. This one will be approaching this end approaches the horizontal asymptote like this. Okay, now for -1 and 1.3 to the left 1 and up 1 and about 1/3 of the way. And then for 1 and -1.3 will be to the right 1 and down 1 and approximately 1/3 of the way. Here's what this part of the graph will be doing. It's going to come up and approach this first vertical asymptote like this. This end comes down like this and approach the other vertical asymptote like this. And by the way, this is one of those graphs where the graph of it will be crossing the horizontal asymptote. Now for the other points, 3 and 2.4, to the right 3 and up 2 4/10 of the way, like this. And then 4 1.3, 4 1 1/3, and then 5 1.0, which is not exactly 1, but it's close to 1. So I'm going to put it about right here. So I know this end comes up like this, approaching the second vertical asymptote. This end approaches the horizontal asymptote like this. And you can see that it is symmetric with respect to the origin, because this end, this part, and this part, if I fold it along y is equal to x, or y is equal to negative x, this one will probably lie on top of this. And this top part, if I rotate it, would lie on this bottom part, like this. Okay? So that's how we graph this function f of x equal to 4x over x squared minus 4. And hopefully this would assist you with doing one of the homework problems in section 3.5.